Let's get started on Module 5, Virtual Networks and Virtual Switches. This module is broken into 3 lessons: an introduction to vSphere standard virtual switches, configuring virtual switch policies, and an introduction to vSphere distributed virtual switches. But before we talk about virtual switches, let's do a review of the physical network infrastructure. A physical switch, as you know, is used to connect servers to servers, to connect users' workstations to servers, and to connect everyone to the router, which connects us to the Internet. There are 4 types of networks associated with an ESXi host: production network, storage area network, management network, and vMotion network. Let's look at each one of those 4 types of networks. Now, I think everybody knows what the production network is. The users stand at their workstations, which connects to a switch, which connects to a network interface card, which connects to the ESXi host. And the purpose of the production network is to connect user traffic to virtual machines. Everybody knows what the production network is. Another type of network is the storage area network. And the purpose of the storage area network is to allow multiple disk arrays to connect to the ESXi host. And the storage area network carries traffic from virtual machines on the ESXi host to the disk arrays. A third type of network is the management network. And this is the management workstation. This is where you or I would log in. It's where the network administrator would connect to the ESXi host, and you might say, an entire network segment just for me? Well, if this network is all congested, and if the storage area network is all congested, then you still have the management network, which allows you to get to the ESXi host to configure it. The purpose of the management network is to configure ESXi hosts. A fourth type of network is the vMotion network. And a vMotion network connects ESXi hosts together. A vMotion network carries traffic between ESXi hosts. And we will talk more about vMotion later. 4 types of networks associated with an ESXi host: production, storage area network, management, and vMotion. And there are essentially 2 configuration options. You can have a separate physical network for each type of network, or they can all be on the same physical network. Now, ideally, you will have a separate physical network for each type of traffic. A separate network for production, a separate network for storage area network, a separate network for management network, and a separate network for vMotion. But the problem with that is it can be kind of expensive. Now, at the other extreme, we can have all 4 types of network traffic on one single physical network. The production network, storage network, management network, and vMotion network, if they all share the same physical network, the problem with that is congestion. Everybody slows down. Ideally, you have a separate physical network for each type of network traffic, but we rarely get to have the ideal. Most commonly, what you're going to see is 2 physical networks and 2 types of traffic on each physical network. Here is the example. Many institutions have it set up this way. They have their production network and their management network on the same physical network. And that kind of makes sense, because here is you, the network administrator at your workstation, so you would use the production network to perform network management tasks. And frequently we see the storage area network and the vMotion network are also combined onto one single physical network. Ideally, each type of traffic gets its own network, but usually you've got to combine types of traffics on the physical networks. To review, A switch connects servers to servers and workstations to servers and everybody to the internet. And four types of network traffic include production traffic, which is user traffic, storage area network traffic, management traffic, and vMotion traffic. We can have all of these different types of traffic on separate physical networks, or they can be all on the same physical network. And this is all true for the physical network infrastructure, and it's also true for the virtual network infrastructure. So let's move on to discussing vSphere standard virtual switches. As you know, a physical switch connects servers to servers, users' workstations to servers, and everyone to the internet. Similarly, a virtual switch connects virtual machines to virtual machines, and it connects virtual machines to the physical network interface card, which connects to the physical switch, which connects to the user's workstations, and which connects to the router. This diagram shows that VM2 and VM3 are connected to each other using the virtual switch. It shows that virtual machine 1 is connected to the virtual switch, which connects to the physical network interface card, which connects to the physical switch, which connects to the users. Let's examine a virtual switch on an ESXi host. This is an ESXi host, and this diagram is supposed to represent an ESXi host. Virtual machines run in an ESXi host, and an ESXi host has at least one network interface card. That network interface card connects to the physical switch, which connects to the user's workstations, and which connects to the internet. So the question is, how do all these different virtual machines connect to one physical network interface card? And the answer is a virtual switch. A virtual switch is a piece of software that emulates a physical switch. And the purpose of the virtual switch is to connect virtual machines to virtual machines and connect virtual machines to the physical network interface card, which connects to the physical switch, which connects to the users and to the internet. Here's another diagram that shows the same thing. Virtual machines can connect to a virtual switch to connect to other virtual machines or to connect to the physical network interface card, which connects to the physical switch. Let's now examine the default virtual switch, and we are going to use the vSphere desktop client. And the reason we are going to do that is because it allows us to connect directly to an ESXi host. The vSphere web client does not allow us to connect directly to an ESXi host. It is only used for configuring vCenter server. So we see here the vSphere desktop client, and here is an ESXi host. I select the tab which says configuration, and then under hardware I click on networking. And then we can see that this vertical bar is supposed to represent a switch which is turned up on its end. And you can see this switch is connected to one physical network interface card, which connects to the physical switch, and it's also connected to a port group. And this port group contains multiple virtual machines. These multiple virtual machines connect to the virtual switch, which connects the physical network interface card. We have another port group, the management network, and of course that's what you and I use to manage the ESXi host. If I click on Properties and click on Edit, we can see that this virtual switch has 120 virtual ports, meaning we could set up 120 virtual machines to connect to this virtual switch, and we could increase this number if we needed to. And if we look under Network Adapters followed by Edit, you can see that we can configure our network interface card to run at 10 megabits per second, and we might do that for backward compatibility with an old operating system that we are installing, but typically we configure it and leave it at auto negotiate. Now let's discuss VLANs, virtual local area networks. ESXi supports 802.1q VLAN tagging, and ESXi supports virtual LANs by allowing us to assign a VLAN ID to a port group. But let's do a brief review of VLANs. If I had a single segment network, but I wanted to divide it into two separate networks for purposes of segmentation and traffic control, what I could do is I could purchase a second switch and then hook half of the workstations to one switch and hook half of the workstations to the other switch, and I will have effectively separated these workstations onto separate segments. I would want to do that to limit the broadcast domain, to reduce traffic congestion, and for purposes of security. But the problem is, if I only have one switch and I don't have the funds to purchase a second switch, how can I separate the computers into separate local area networks? And the answer is to use a VLAN, a virtual local area network. A VLAN is where we take our single physical switch and we logically divide it into separate logical subnets, such that these workstations are isolated from these workstations. And this is effectively the same thing as purchasing two switches, putting half of the workstations on one switches and half of the workstation on the other switch. A VLAN divides our network into logical segments. A VLAN on a virtual switch can be done by assigning a VLAN ID to a port group. So let's do it. Let's assign a VLAN ID to a port group. To assign a VLAN ID to a port group, I go into the vSphere desktop client, to my ESXi host, to the configuration tab. Under hardware, I click on networking. Then I click on properties, and you can see I have several port groups. I select the first port group and click on edit, and then I can assign it a VLAN ID of 1, for example. I can select the second port group and click on edit and give it a VLAN ID of 2. And that way I can separate these workstations onto separate segments. A VLAN effectively allows you to separate your virtual machines onto separate logical segments. A virtual local area network allows you to logically separate groups of virtual machines, to segregate traffic, to limit the broadcast domain. And the way you do it is by assigning a port group a VLAN ID. Lesson 2, configuring virtual switch policies. The 3 policies we are going to configure will be security, traffic shaping, and network interface card teaming policies. If I go to my ESXi host under the configuration tab and I click on networking, and then I click on properties, followed by edit, you can see there are 3 tabs across the top: security, traffic shaping, and network interface card teaming. I will select the security tab. The first item is promiscuous mode, and when you enable promiscuous mode, it allows the virtual machine, or all of the virtual machines in the port group, to listen to all traffic which is being sent to and from all other virtual machines on the virtual switch. You would probably want to do this if you were using a protocol analyzer. A protocol analyzer is a program that allows you to examine all traffic on the network. Good guys use protocol analyzers to solve network problems. Bad guys use protocol analyzers to steal passwords and credit card numbers. So if you are going to use a protocol analyzer to allow this virtual machine to listen to all traffic coming to and from all other virtual machines, I would select the drop down for promiscuous mode, and then I would select accept. And then there are two other options here regarding MAC address changes and forged MAC transmits. Typically, a virtual machine is not going to change its MAC address. The only exception would be if you were using Microsoft Failover Server, whereby the virtual machines do change their MAC address, but usually it's not an issue. Now let's look at traffic shaping. Traffic shaping prevents some virtual machines from gobbling up all of the network bandwidth and then leaving none for everybody else. If we see that network utilization is excessively high, and if we see that a virtual machine or group of virtual machines is responsible for that high traffic, then what we might want to do is implement a traffic shaping policy. Network traffic shaping is a mechanism for controlling bandwidth, for preventing one virtual machine from taking all of the bandwidth from everybody else. So here's how we do it. Under the Traffic Shaping tab, under Status, we select the drop-down and we select Enabled. And then we specify that the average amount of bandwidth that can be used by this virtual machine is 100 megabits per second. Now, there might be times when this virtual machine really needs the entire bandwidth. So under peak bandwidth, I will change that to 1 gigabit per second. And that way, the virtual machine will get to use all of the bandwidth. But notice the burst size is limited. So the virtual machine will get all the bandwidth, but only for a limited amount of time. So what this does is it makes it so most of the time, this virtual machine only gets 100 megabits per second. And it occasionally can use the entire bandwidth, but only for short periods of time. The next item to discuss is network interface card teaming. And network interface card teaming is where you have multiple network interface cards working in tandem. Notice there are 2 physical network interface cards in this ESXi host. So it leads to the question, why would you have 2 network interface cards in an ESXi host? And there are 3 reasons: fault tolerance, load distribution, and the ability to connect to separate physical networks. Let's look at the fault tolerance example first. If you had an ESXi host and you had 2 physical network interface cards, if one of them went bad, that's okay. You would have the other one there to handle all network traffic. And this is called fault tolerance. If one of them fails, that's okay. The other one is there. This is what they call failover. Failover simply means one fails, then the other one steps in and takes up the slack. If we go to the virtual machine and select Properties under Edit, under Network Interface Card Teaming, we can see it's configured to use explicit failover, meaning if this network interface card fails, that's okay. This standby adapter will then take over. Notice there's an option here that says fail back. Fail back is configured for yes. Now, fail back is when the first network interface card comes back online, and then all traffic can then go back to the first network interface card. This is called failback. Failback is when the first one comes back online, and then all traffic goes back to the first network interface card. Failback is typically configured for yes. Why might you configure failback for no? Here's the answer. You might configure failback to no in the case where the first network interface card is intermittently bad, and that would prevent flip-flopping from the first network interface card to the second network interface card. 2 network interface cards in an ESXi host. The first reason you would do it is fault tolerance. A second reason that you would have 2 network interface cards in an ESXi host is for load distribution. So let's look at that example. if we have two network interface cards for load distribution, well, if we have one network interface card, then the greatest throughput we could have would be 1 gigabit per second. But if we have two network interface cards working in tandem, then they can provide double the amount of bandwidth. And why do we do that? For greater speed. If we look at the configuration of this virtual switch, we can see it's not configured for load balancing. If you look at it, we have an active adapter and we have a standby adapter. And what that means is that the standby adapter doesn't do anything until the active adapter fails. Well, I want them both to be active adapters, and that will double my amount of throughput. So I take this standby adapter and I click on Move Up. And when I click on Move Up, now we can see we have two active adapters. And if we have two active adapters, that means we're going to have 2 gigabits per second instead of just 1 gigabit per second. Notice we have these load balancing methodologies across the top: root based on originating port ID, based upon IP hash, based upon MAC hash. Let's take a look at those different load balancing methods. Now, one load balancing method is called originating port based ID. The purpose of this load balancing method is to ensure that an equal number of ports are assigned to each network interface card. And it uses a round robin method of load balancing. Here's how round robin works. When the first virtual machine is turned on, it's assigned to the first physical network interface card. When the second virtual machine is turned on, it's assigned to the second network interface card. When the third virtual machine is turned on, it's assigned to the third network interface card. And when the fourth virtual machine is turned on, it is assigned to the first network interface card. This is called round robin. The purpose of round robin is to distribute the load across the physical network interface card. Now, the disadvantage here is that if virtual machine 1 and virtual machine 4 both have a tremendous amount of traffic, they will still be sharing the same physical network interface card. A second drawback in this load balancing method is that one virtual machine cannot send traffic over two network interface cards simultaneously. A second load balancing method is called source hash based, and it's very similar. The purpose is to ensure that an equal number of MAC addresses are assigned to each network interface card, and it too uses a round robin load balancing method. Once again, the limitation is that one virtual machine cannot send traffic over two network interface cards simultaneously. The third load balancing method, called Link Aggregation Control Protocol, allows us to distribute the traffic across multiple network interface cards, and most importantly, it allows one virtual machine to send traffic across two network interface cards simultaneously. Of course, the drawback is that requires that your switch support Link Aggregation Control Protocol 802.3a, and not all switches support that protocol. The default load balancing protocol is root based on originating virtual port ID. It uses a round robin methodology. So that was using two network interface cards for load balancing, or using two network interface cards for load distribution. A third reason for using two network interface cards is to connect to separate physical switches to connect to separate physical networks. Let's look at creating additional switches. Now, you might say, if there's already a default switch, why would you create another switch? Why would you have another switch if there's already one built in? And the answer is because you want to connect to multiple physical networks. So here's the example. We have an ESXi host which has multiple virtual machines, a single physical network interface card which is connected to a single physical switch, and we have the virtual switch which connects the virtual machines to the physical network interface card. Now let's say that we added a separate physical network. There's an additional switch, and we add a second network interface card, and we put it in the ESXi hosts. Now I want to make it so the virtual machines on the right only connect to the physical network interface card on the right. So what I do is I create a separate virtual switch, and then I configure it so these virtual machines connect to this virtual switch, which connects to this physical network interface card, which connects to this physical switch. And then these virtual machines over here connect to this virtual switch, which connects to a different network interface card and which connects to a separate physical switch. So let's do it. To create a new physical switch, on the upper right hand corner I click on Add Networking, and the connection type will be a virtual machine connection type, followed by Next. Then I don't select virtual network interface card 0. That's already in use. That's the first network interface card. I select the second network interface card, NIC 1, to be used by this virtual switch. Then I click on Next. I give the port group some name, such as Research and Development, and I click on Next, and I click on Finish. And now you can see that a second virtual switch has been created. This is our original virtual switch, and this is the virtual switch we just created. That virtual switch is hooked up to a physical network interface card, but notice in the port group there are no virtual machines attached. So the next thing to do would be to move one of those virtual machines from one virtual switch to the other virtual switch. So here is how we do that. I go to one of the virtual machines, such as Database Server 2, and I right click on it and I select edit settings, and under Network Adapter I can see it is currently connected to the default virtual switch. So if I select the drop down, I can select the Research and Development port group, which is associated with the new virtual switch. If I then go back to my ESXi host, back to the network configuration, I can now see that the new virtual switch now has the Database Server 2 virtual machine as part of the virtual port group, which connects the virtual switch, which connects to the physical network interface card. You can use switches to connect different virtual machines to different networks, and what that will do is it will segment the network traffic, and it will isolate these virtual machines from these virtual machines because they will be on separate physical segments. 3 reasons to have multiple network interface cards: fault tolerance, load distribution, and the ability to connect to different switches. In the next section we will talk about distributed virtual switches. And this concludes part 1.